Okay, with this in mind, I would like to go into our global stiffness matrix and just talk about where the matrices are going to be added on. Okay, I should mention here, of course, that each of the entries in these KE1 and KE2 matrices is a it's not a scalar, right? What is it? Each of these is a, that's right, a 3 by 3 matrix, right? Okay. All right. Okay. Right, and that's the same for KE2. All right. So now let's look at our global K-bar matrix. Okay. And in setting it up, okay, let me suppose that this is row A, row B, row C, and row D. Okay. And in terms of columns also, I have I may have A here, B, C, and D. All right. With all of this in place, let's look at which sub-matrices from the KE1 and KE2, which I wrote in the previous slide, are going to make their appearance here. Okay, so let's look at the AA contribution. Okay, for the AA contribution, we will have, which would be here, right? We would have from KE1, right? If you look back at the figure I drew of the two elements E1, omega E1 and omega E2, it should be clear that from KE1 we have the 6 component, right? And from from omega E2 we have the, which one? That's right, 5 component. Okay. You know, if we filled out all the A, B, C, Ds here, we would have 16 entries. So I'm not going to try to do all of that, right? So let's look instead at what happens with the CC entries. Okay, so the CC entry from E1 would be KE1 22 plus, from E2 to be KE2 11. Okay, and this would go on. Of course, neighboring omega E1 and omega E2, there may be other elements which also share our global nodes A, B, C, D, right? And contributions from those elements, stiffness matrices, would also be added in here and here, right? So okay. Okay, now let's look at what happens with a with maybe the AB combination of global nodes. Okay, so if we look at AB, what we observe is that the contribution from element E1 is going to be of the will be from the matrix KE1. What do you think? Which particular block is going to contribute here? It would be the 6, 7. Okay, and from E2, it would be the, right, 5, 8. Okay, and so on. So let's do one more. Maybe we do the, what do I have room here for? Let me do the AD. Okay, so AD from KE1 is going to be 6, 4, and from E2 is going to be, oh, I'm sorry, from E1 it will be 6, 5. Right, and from E2 it would be I'm sorry, I can't read my own handwriting here. It will be 6-3. Really sorry. 6-3 from E1, and from E2 it would be 5-4. Let me double check that. Okay, and of course there will be other contributions from other neighboring elements that share the same nodes. Okay, so this is our global k-bar matrix, right? With this in mind, let's also try to assemble our forcing vector. Okay, I believe that with this in place, we can do this. We can assemble the forcing vectors fairly quickly. Okay, so what we see here is that when we look at our sum over elements, CE transpose F internal E. Okay, now we have this written as C transpose F internal, right? Okay, where we already know what the C vector is. We only need to say what the F vector is. Okay, and since I have some room here, let me try and write out the F vector here. Okay, and I'll try to do it for the same combination that we have. Okay, so the F internal vector. So for the same, I'm going to try to do this for the same combination of nodes that I've written out for that I've used for the stiffness matrix. Okay, let's do this. Hopefully that gives me enough room, and let me say that the nodes A, B, C, and D make their appearance at roughly those points of the vector. Okay, global node A, what contributions does it get from element E1? Right, from element E1, it gets the F internal E1 from which local node of element E1? Right, local node 6. And from E2, it gets a contribution from local node 5. Right, this continues, and let me try to do the same for global node C. So from element E1, it gets F E1 internal node 2, and from E2 it gets F internal 1. Okay, right, and of course there could be more contributions here, right, because of the fact that there are more elements off to the side, right? Okay, so all of those contributions would go into those entries for global nodes A and C. Okay, so that's how we set about assembling our global stiffness matrix K-bar and our global force vector F internal. We'll end the segment here. When we come back, we will talk about how we treat the traction or the Neumann boundary condition terms.